Midsegments of triangles. So the triangle midsegment theorem states that if you have three sides of a triangle, which I'm going to highlight in two different colors, if we have three sides of the triangle and a segment joins the midpoints of two of the sides, which are the two that I highlighted in purple, if you have a segment connecting those two, then that segment is parallel to the third side and is half as long. The segment I just traced over in orange is parallel to the original segment I highlighted in green. If you have midpoints of a segment, so these points here, midpoints of a segment create equal parts. So we have two equal parts of this segment and two equal parts of this segment. If we took a couple notes on this model, we could say that D is the midpoint of segment CA, and E is the midpoint of segment CB. If this was the case, we know that the two lines I highlighted in green, which are segment DE and segment AB, are parallel. Don't forget your parallel symbol. We also know that segment DE is 1/2 of the length of AB. So the equation would be DE equals 1/2 times AB. If I was to write in some numbers here, let's say segment AB was a length of 10. If AB was 10, then segment DE would be a length of 5. Before we get into the algebraic equations, let's just take a look at a few more models. The first one is asking us to identify three pairs of parallel segments in triangle ABC. So ABC is this larger triangle here. However, we have many small triangles within that. And you can see that we have a lot of congruent segments. If you have congruent segments, then you have a midpoint. Let's start with segment AC. AC has broken or is separated into two congruent segments, which indicates that X is the midpoint. If we look at segment AB, we have two congruent segments here. That indicates that Y is the midpoint. I'm going to abbreviate that as MP. And if we look at segment BC, we have two congruent segments here as well. Therefore, Z is the midpoint. So the midsegment theorem indicates that we have multiple sets of parallel lines, and I'm going to highlight them. So if we start with this midsegment, we know that it's parallel to this side. If I list that, I'm going to say segment YZ is parallel to segment AC. If I highlight this as a midsegment, because it's connecting these two sides, segment YX is parallel to segment BC. And lastly, if we highlight this as our midsegment, because it's connecting these two sides, segment ZX is parallel to segment BA. Okay, I'm going to complete number 2. If you guys would just follow along, you'll see I label it the same way I did with number 1. For the next example set, we're going to be using the fact that the third side is the midsegment is half the length of the third side. So we're going to be completing some algebra in order to find missing side lengths of this triangle. So in triangle XYZ, J, K, and L are the midpoints. That's stated right here. I'm going to highlight them. We're looking to find the lengths of segment LK, JL, and XK. In order to do this, we are going to use the relationship that the length of the midsegment is half the length of the third side. So let's start with this as our midsegment. That midsegment connects these two sides of the triangle. So if those are the connecting sides, the third side is this side I'm highlighting in green. And that tells me that that third side is twice the length. If we start with segment JL, JL is the midsegment and it is half the length of XY. XY is the length of 20. So when I substitute in these values, I have 1/2 times 20, which is 10. The length of JL is 10. Of course, you could do that in your head, I think. 20 divided by 2 is 10. Let's switch and use another midpoint. So let's look at segment LK. Segment LK is here. It connects these two sides, which means the third side is XZ. XZ is twice the length of LK. When I substitute in the value, we have 1/2 times 12. 1/2 times 12 is the same thing as 12 divided by 2, which is 6. Again, very simple. Hopefully you can complete that. Most of the time, complete it in your head. And the last segment we're looking for is XK. XK is this segment here. So this is not using the midsegment theorem. XK is going to recall or require you to use previous theorems about midpoints, which indicate if a midpoint is a point on a line, it divides the line into two concurrent segments. So if the total segment length of XY is 20 and you have a midpoint, half of that line is 10. the length of xk is equal to 5. Oh, sorry, the length of xk is equal to 10. I wrote that backwards, jumped ahead. 1/2 times 20. The length of xk is 10. For this problem, I need you to add an extra piece of information. I need you to add that z is the midpoint of segment MO. And I'm going to mark all of your midpoints for you. Recall that midpoints create congruent segments on each side. And I want everyone to answer this problem by yourself. If you could press pause on your video and then come back to check your answer, that would be great. And for the last example, we're looking at a real-life model of a bridge. And it says that segment CD, which is the segment crossing over, or you could call it the bridge over this body of water. Segment CD is being built over a lake. We want to know what the length of the bridge is. If you notice, I just marked C and D as midpoints, and the reason why I did that is because on each side of point C, we have a segment that's 963 feet. So on each side of segment C, we have 2 congruent segments. And on each side of point D, we are given indicators that we have 2 congruent segments. So if those 2 parts of this figure are going to be the midpoints, that means it's connecting these 2 sides. And the third side of your triangle is here. If you're looking for the length of the bridge over that body of water, that bridge has to be half the length of the third side of the triangle. So I'm going to write CD is equal to 1/2 times the length, which is 2,640 feet. In this case, CD is equal to 1,320 feet. Because this is a real world problem, I'm going to write my final answer as a sentence, and I'm going to say the length of the bridge is 1,320 feet.